Go. And that's one-dimensional motion. See, Mr. Day, I'm right here.
This is Johnny practicing his golf swing, and this will be defined as two-dimensional motion.
Alright, this is Newton's first law. An object will stay in motion and remain in motion until acted upon by an outside force. Go ahead, Mason. Boom, there's the outside force which stops the ball, and I am Jeremy.
I'm with Johnny, and this is Newton's second law. A ball will accelerate and then change direction. Ready, look!
Alright, Newton's third law states that there is a force pushing down on Mason, and there's a counteracting force of the chair that is keeping Mason from falling on the ground. And when you take away this force like this, Mason will fall. And that's Newton's third law.
That is Johnny holding a golf ball and a baseball. This is free fall, which states that it doesn't matter of the mass, both of them will fall and hit the ground at the same time because of gravity. Go.
This is air resistance, and we put a paper bag around the golf ball to slow its acceleration down to the ground below, and we'll test it out right here. As you can see, the golf ball slowed down and the baseball hit first. Alright, this is kinetic force, which is force that you create to go up a hill, such as my driveway, and here's Mason going up the driveway. As you can tell, it's kind of hard for him. He's struggling. But that's kinetic force that he just created. Alright, this is potential energy, which states that at the top of a hill, the potential energy is greatest, and as the ball rolls down the hill, it loses potential energy. Because once it gets on a flat and stops, it has no potential energy left. So now that it's at the bottom of the hill, it has no potential energy.
Elastic energy is when something is pulled back, elastic, and shoots to make acceleration.
Example. Boom. Conservation of mechanical energy is when something is rolled and friction causes it to lose energy, but if you add the frictional force and the mechanical energy in the beginning, it will equal the mechanical energy in the end. As you can see, the carpet slowed the ball down because of the friction. This is an example of Mason doing work, which work is taking a heavy object like this dumbbell and raising it up to a specific height. He has to do a certain amount of work to get it up to that height. Go ahead, Mason. Whopping 15 pounds. Don't drop it. Alright, this is impulse momentum theorem, which states that an object moving in, which the first object is the baseball moving in, and the second object, the bat, when it is swung, will hit the baseball and accelerate the baseball and change the direction. Go ahead, Mason.
Oh my God.
Elastic collision is when two objects collide and go in different directions. Ready, go. Inelastic collision is when two objects combine and move in the direction in which the force is applied. As shown.
Alright, this is circular motion and centripetal force. This rock is tied to a string, and this would be circular motion above my head. And the centripetal force is the force on the string that the rock's putting on staying in the circle. Okay, this is torque. If you use torque to loosen a bolt with a wrench, it's like the amount of force you need to make something turn around an axle. So, as you can see, I'm loosening this bolt right here.
This is a screw, and it is used to tighten up the clamp, as you can see.
You should know that.
Alright, this is an inclined plane, which the ball will roll down, which helps us get to the ball where we need it to be at the bottom of the steps, next to the camera girl's feet. Boom. Alright, this is a wedge, which is an axe, and it is used to chop wood. It creates pressure down the middle and splits the two pieces in half. Let's see the almighty Mason miss. Boom, split in half. Alright, this hammer acts as a wedge to get this nail out of my stepsil that got 72%, by the way, in wood shop. And let's demonstrate it here, Mason. Boom. Gets.
This is a pulley. Whenever a force is applied down, the rock on the string will raise from the pulley.
Alright, this is a wheel and axle. The pedal, when cranked like this, spins the wheel on the axle. The axle, for you who don't know, like Mason. And that is what our demonstration is.